March 1945, the West Bank of the Rhine. German staff officers are doing the math, and the math is supposed to comfort them. The Rhine is the last true barrier of the Reich. 300 meters wide in places, fast-moving, and every permanent bridge across it has either been destroyed on Hitler's standing order or is being wired for demolition right now. German planners expect any major crossing here to take considerable time and heavy preparation, and for most of the war that assumption has held up. A permanent bridge could take months to rebuild, blow the crossings, and the Rhine should buy weeks, maybe longer. It's the same calculation that has worked for the retreating Wehrmacht again and again since Normandy. Blow the bridge, force the enemy to stop and rebuild, buy time. Except the enemy doesn't rebuild the way German planners expect. On the 26th of March, 1945, Royal Canadian Engineers of the 2nd Canadian Corps start assembling a floating bridge at Rees, downstream from Wesel. Fog slows them down, component barges show up late, and still, by midday on the 28th, there's a bridge stretching more than 1,800 feet, ramps included, open to traffic, rated for 40 tons. That means tanks. The Germans got roughly 48 working hours between. This will take considerable time, and there is now a road across the Rhine wide enough for Allied armor. The Canadians called it Blackfriars Bridge, after a crossing on London's Thames, and it turned out to be the longest Bailey Bridge built during the whole war. Not concrete, not steel riveted together in a shipyard somewhere, pinned together, panel by soldiers with hammers and wrenches. The Wehrmacht had good bridging equipment of its own, plenty of experience with pontoons and assault bridges. What it never had was anything this modular, this easy to mass produce, this scalable. A bridge you could carry in a truck bed, assemble without a crane, and drive a 40-ton tank across the same afternoon you built it. That's the whole story here. The bridge, the civil servant who spent over a decade refining an idea nobody in the War Office wanted, and how a piece of equipment this unglamorous ended up mattering as much as it did. Start in a government office in Christchurch, on the south coast of England, more than a decade before the war. In 1928, a young engineer named Donald Bailey took a civilian post at the Experimental Bridging Establishment, a small, chronically underfunded unit of the Royal Engineers testing portable bridges left over from the First World War. Bailey was a Sheffield University graduate who'd already worked for Rowntree's, the confectionery company, and for a railway, before landing in military bridge design of all things. Not glamorous. Budget cuts in the early 30s trimmed his unit down to himself, one officer, a draftsman, and 14 men in the workshop, and the cuts got bad enough that people in government started asking whether his little department should exist at all. By 1936, Bailey already had a rough design sketched out for something better, but the War Office wasn't interested yet. The existing bridges, older box girder and tubular designs from the First World War, could carry about 26 tons, fine for the tanks of that era. Then the war started, and tanks got heavier. The Churchill tank, entering service in 1941, weighed somewhere around 39 to 40 tons. No amount of tinkering was going to stretch the old designs that far. Late in 1940, driving home from yet another meeting where officers argued over the bridging problem, Bailey sketched a refined version on the back of an envelope, an idea he'd been chewing on for years by that point. Identical steel panels, about 10 feet by 5, roughly 570 pounds each, light enough for a few soldiers to lift by hand. Pinned together end to end, no crane needed, doubled or tripled up for extra load capacity. Every piece fit in a standard 3-ton army truck. A basic bridge could go up in a few hours. Bailey himself, years later, talked about his lifelong fascination with the problem. Water, he said, is a damnably difficult thing to tamper with. The design went from prototype to full production in under a year, which is fast for military engineering by any standard. On the night of November 26, 1942, it got its first combat test. The 237th Field Company, Royal Engineers, threw one across the Medjerda River near Medjez el Bab in Tunisia. It held. From there it spread through every Allied army in every theater. In Sicily, the 3rd Field Company, Royal Canadian Engineers, built the first one ever assembled under actual enemy fire at a village called Leonforte. In Italy, The U.S. Fifth Army and British Eighth Army put up more than 3,000 of these bridges between them, over 55 miles of bridging by the time the campaign wrapped, averaging around 100 feet a span, though a few, like the one over the Sangro River, stretched past 1,000 feet. Montgomery, who commanded the Eighth Army through that campaign, said later he couldn't have kept his advance moving at the pace it did without a steady supply of Bailey bridging. Another time, he put it more bluntly, without the Bailey Bridge, he said, the Allies couldn't have fought the campaign the way they did. By DDAY, the design had been licensed to American manufacturers too, who called it the Portable Panel Bridge, and started mass-producing it alongside the British. Over 600 separate firms built components across the war. Something like 700,000 individual panels got manufactured by 1945, adding up to over 200 miles of bridging. In Normandy, engineers threw them across the Caen Canal and the Orne River within days of the landings, under artillery fire, because they'd rehearsed the exact sequence dozens of times in Scotland beforehand. During Market Garden, in September 1944, when the bridge at Caen got blown before Allied paratroopers could grab it, engineers had a Bailey Bridge in its place fast enough to keep armor moving toward Nijmegen. Every time the retreating Wehrmacht blew a crossing hoping to buy real time, what showed up in the next French or Belgian town was usually a matter of hours, sometimes a few days. Almost never the weeks German planners were counting on. The human cost is easy to miss in the numbers, so it's worth slowing down on one bridge specifically. In March 1945, American forces captured the Ludendorff Railway Bridge at Remagen intact, the first crossing of the Rhine to fall into Allied hands. Engineers spent 10 days shoring it up under constant German air and artillery attack, plus repeated demolition attempts. It finally gave out on March 17th, killing 33 American engineers and wounding 63 more. But by then, those same engineers had already finished a treadway bridge and a pontoon bridge right alongside it, and a Bailey Bridge followed soon after. More than 125,000 troops, 6 divisions worth of tanks and artillery and trucks, crossed at Remagen in the weeks that followed. 33 men died keeping that crossing open. They're a big part of why the Rhine will hold for weeks, kept turning out to be wrong by a matter of days. Eisenhower, looking back on the war, called the Bailey Bridge one of the most important engineering developments of the entire conflict. Coming from the Supreme Allied Commander, about a bridge held together with hand-driven steel pins, that's a strange thing to say, unless you think about what actually decided how fast an army could move. Not just whether you had tanks and planes, but whether you could keep moving after the enemy wrecked the ground in front of you. Germany, for all its engineering talent, poured a lot of its effort into fixed things. The Atlantic Wall, the Siegfried Line, permanent fortifications built to hold a line. The Allies built part of their war around a kit that assumed every crossing would get destroyed and planned around that assumption from the start. A system built not to hold ground, but to keep replacing whatever the enemy took away. The Wehrmacht knew how to blow up a bridge as well as anyone in Europe. What it never quite priced in was an opponent who'd already made that particular problem cheap to solve, using a design that started as one civil servant's idea inside a department the Treasury once wondered if it should bother funding. Bailey got knighted for it in 1946. He died in Bournemouth in 1985, and a section of his bridge still stands in Christchurch, near the barracks where he spent over a decade on it, before anyone in the War Office cared. He's not a famous name. Most people who cross a Bailey Bridge today, and there are still thousands in service around the world in disaster zones and remote regions, have no idea who he was or what his design did in 1944 and 1945. The German officers standing on that riverbank in March 1945, doing their careful math about how long a blown bridge should buy them, were up against a man who'd already spent years working out the answer on the back of an envelope on a drive home from a meeting nobody thought would matter. If a story like this is worth telling, the men who built these bridges under artillery fire And the ones who didn't make it home from doing it are worth remembering, too. That's really what this is about, not the steel. The people who carried it across a beach or a canal or a captured riverbank because somebody had to, and it was going to be them. If you want the next one of these, subscribe. There are more stories like this waiting.